Okay, something before we get started. What we've been talking about in Chapter 9 is business intelligence systems. So, using data, applying techniques to it, coming out with information. So, what kind of goes hand in hand with that is a guest we have in tomorrow. He is, I think his title is data analyst for the Pittsburgh Pirates. Okay, so baseball has been around in the sport for over 100 years. Yet they're changing it, they're making it better, right? Even though there's been millions, thousands and thousands of professional games played, they're using data, unprecedented data, to make better decisions, shifting, player analysis, all those things. So it uses a lot of the things we're talking about in this chapter. Unfortunately, we don't have our class tomorrow, right? Tomorrow is Thursday. We don't meet Thursday. So I would like you guys to see it, and what I can do is, if you'd like to see him, you can come to one of the classes he presents in, and I will give you, I don't know, 2 bonus points. Now, I know some of you are already going to see him because you're in stats, so I'll have to make the offer to you as well, but to get the 2 bonus points, you have to write a paragraph about what he spoke about, right? Just a paragraph, all right? So he'll be in Paddle 110 at 9:30 tomorrow. He'll be in SCOTUS 206 at 11 a.m. tomorrow. He'll be in McFadden's class at 1:15. Does anyone know where that is? Paddle 110 at 1:15. He'll be in Business 101 at 2:45. Does anyone know where that is? Come see me. Find it together. But anyways, he's relatively young. I think he's 29 years old. MIT graduate, and these are the techniques that he works with every damn day. Okay, so he works hand in hand with the manager of the team to make decisions about how they're going to pitch people, how they're going to play defensively, and all those good things. So I think it kind of ties into our chapter to someone actually using these techniques to manage more effectively in an organization. So I will finish chapter 9 today, but kind of want to review a little bit about what we talked about last class. And we talked about data mining, right? And there were 2 types or 2 categories of data mining that we talked about. And we said there are unsupervised data mining techniques and supervised data mining techniques. What are the differences between the 2? What is unsupervised or supervised data mining? So data mining is analyzing data, looking for patterns or relationships that help us manage that or make us make better decisions. What's the difference between supervised and unsupervised data mining? Anyone? Sarah? Okay. So supervised data mining, I say, I think temperature influences ice cream dough, right? So let's go into the data and see if there's evidence to support that. I think that when college is in session affects my sales at LPG, right? So let's go see if there's data to support that. That's called a supervised data mining. Is there evidence to support my hypothesis? Yes. And a big thing that's used there is something called regression analysis. If you've taken statistics with me, you will see it already, and you'll see it more in Stat 302. The second technique is unsupervised data mining. So we're going to look at the data and see if we can find patterns or relationships that can help me make decisions. And the one type that we talked about was market basket analysis, right? And that's a big technique. It's a common technique that's been used for years and years, but now it's getting more and more mainstream, more and more robust. So what are the things that people buy together? So that can cause us to make the right cross-sell recommendation. You see it all the time with Amazon. People bought this, also bought that. People that looked at this also bought that. Maybe you'll go and see an ad. How we place things in stores. People that like this on Netflix also like this. People that like this song on Pandora also like this. That is market basket analysis. And there's some terms that I think were important in there. We talked about support. Okay, support is the percentage of times that 2 things are bought together, right? So the combination that, for example, mask and tanks are bought together, it looks like it's 0.025, so not a lot of support there. Fins and masks, 62.5%, so a lot of support. Now that's one good thing. The other thing that I want to look at, though, is confidence. okay? Confidence says, hey, when this thing is bought, what is the conditional probability that this other thing is bought? So think about it. If a mask is bought, hey, the probability of fins being bought goes up to 92%. Fins being bought alone is 70%, of any given customer that comes in our store. But if we know they bought a mask, that goes up to 92%, right? That's what confidence is. The confidence that when they buy this, we have this kind of confidence they'll buy this as well. So we want to analyze that relationship. We want to say, okay, what's the base probability and the confidence probability, and we get a ratio called improvement, okay? And if we look at improvement, what's the line that says, hey, this thing, when it's bought in this, it improves the odds and it decreases the odds? What's the line we want to look at? What's the threshold that says this is better or this is worse? 1, right? So anything in improvement or lift up here over 1 says, hey, they're almost 30% more likely to buy fins if they bought a mask. They're twice as likely to buy, a tank if they bought wings, right? So that shows us the lift we can get. So that's where our recommendation engine comes from. So that was an important concept, right? That's an important concept. And if you work in marketing at any kind of retail thing, you're going to use market basket analysis, guaranteed. That's why we have loyalty cards that are trying to track that information. We also talked about decision trees. Okay, decision trees we can look historically back at our data and say, well, what was the result of this? We gave this person a loan and they ended up defaulting. So what were the characteristics of this person? And maybe 90% of the people that had a credit score less than 800 ended up defaulting. So now we can use that information to make a decision tree so that when a new person comes in, we say, hey, your credit score is less than X hundred, whatever it might be, you don't get a loan because 90% of people like you default. And I think the example I showed you was looking at SAT score and high school GPA. So a lot of universities do that, right? They say, based on your high school SAT, based on your high school GPA, people with your characteristics tend not to do as well as others in this program. So maybe they say we're going to provisionally admit you, okay? You have to prove yourself, or they say you're not allowed in here at all, whatever it might be. Same thing happens with insurance, right? People with these characteristics traditionally more likely have an accent than these characteristics, than these people. That's called a decision tree, right? That is a form, of unstructured, unsupervised data mining, okay? So I want to talk lastly, two things, 2 other concepts in this chapter that I want to talk about. And this one is probably the biggest buzzword in business right now. Okay? It's big data. You ever heard of big data? You hear that buzzword? In MIS world, in the IT world, big data is the buzzword. Okay? Cloud used to be the buzzword. Like maybe 4 or 5 years ago, people talked about the cloud, everything in the cloud, right? Now, big data is probably the biggest trend in information systems. Well, what is big data? What is big data? Anyone know? Anyone ever hear the term big data? No? Where did you hear it, Eric?
I guess like talking about big data, the only time I've ever heard is when you're talking about a lot of data. A lot of it,
Okay. And that's right. That's one of the characteristics of big data. I mean, big data, the volume of data is massive, right? And they liken it to, drinking from a fire hose, like a professional fire hose. It's coming out at that kind of volume, that kind of velocity, that kind of variety, and we're trying to get some information from it, right? Just so much it can be overwhelming, but we want to understand, we want to make sense of it, right? So big data, because of where processing is, it's relatively cheap. Servers, processing power is cheap. Storage is relatively cheap. We have the cloud. We can gather so much data that it can be overwhelming, and it's hard to find, nuggets of information in that data. So big data is data characterized by, volume, high volume of data, coming very fast, and a large variety. Okay, and a good example of this is big data is Google searches, right? So think about how much data Google searches is generating every second, every millisecond of every day. And think about it. It's a lot of data, So when you do a search, Aaron, we search, okay, you searched on this keyword, right? But what else do they gather for that? You know, you search like, I don't know, Ben Carson debate or something like that, right? So what else do they gather from that?
Other, I'm into like politics or something, so they hear other like political data towards me, I guess.
Okay, so you search in Google Ben Carson debate, yes? So that's some data. They just gathered some data. And maybe a million other people search, you know, around the same time for the same thing. So they don't just store what you search for, but they store, hey, he searched for it on a IBM Lenovo or a Lenovo laptop, right? It was at this time. He's located in this county. You know, we think he's, you know, based on, maybe you didn't tell Google what you were, but we think he's a male. We think he's about 22 years old, whatever it might be, right? So they don't just store, hey, this was searched, but they put all those things with it. Think about that massive data. And you're searching, you know, have you ever looked at your search history? It can be crazy, right? You know, you think, what the hell? You kind of tell what's going on in your life by your search history, right? Like Dr. Miko might be buying a car, and then, you know, he's searching for like, what's the one thing I was watching last night was Get a Chance. There's these monkeys that are trained to pick coconuts in Thailand. I think that's something about that, right? Google that on YouTube. Huh?
I just stumbled on that.
It's on Twitter, and you know, it's one of those wormholes. You're like, oh my god, that's pretty neat. And then, so these, you know, I'm not going to put it on class, but they train these monkeys. You know, a monkey, a good trained monkey, and they're saying these monkeys are like slaves, right? Because they have like monkey colleges to train them. I swear to you. No, we can't go down that hole. But there's these monkeys that they train in Thailand, and they pick coconuts and they climb a tree like nothing, right? And they train them to twist the coconut and throw it down. And then when they're done, they pick like 1,600 a day. The males can pick 1,600 a day. The females, I think, it's like 600. So, but when they're done, you know, the guy has them on a big leash, and they learn how to untangle their leash and all that stuff. That's part of the monkey college. They come down, and then they have to load the truck. These poor monkeys, right? But they're very. Anyways, so that's where your coconuts are coming from. So there's like people saying like, hey, these monkeys are being treated as like pretty cool, really cool, pretty cool. Because then they jump from tree to tree. They don't come down the tree. They go boom, boom, boom. They know how to pick the right ones and all that stuff. So anyway, so if you look at my search, you're going to see that kind of stuff. So what I'm talking about is variety, right? So maybe he's looking at the Ben Carson the debate last night. He's looking at coconut picking monkeys. Maybe he's looking at results of the Steelers game. So think about that variety, right? So that's one of the characteristics of big data. And they say it is least a petabyte, okay? At least a petabyte. You remember we talked about the prefixes? We talked about, giga, right? Petabyte. That's big. That's a power of 1,000. And one of the things when we talked about databases were very, very structured. Remember databases? We said, hey, this is where the name goes. This is where the address goes. Well, big data tends not to be structured. It tends to be, free-form text, like a Google search, like log files, like where you clicked on the screen, how long you stayed with this video. All those things, that is an example of big data. Okay, so what do we do with that data? Well, we've come up with techniques to try to analyze it. It's huge. And one of the things that we call is there's a technique called map reduce. Okay, it's a technique. It's not a program. It's a technique. Map reduce says, we have this cloud. We have multiple computers that are all over the world that have this processing power. So it's going to be impossible for us to run all this analysis on one computer, no matter how big the computer is. It doesn't matter if it's a supercomputer or not. So we take the workload of analyzing all this data and we break it up. Okay, we segment it. We say, all right, you take care of this, you take care of this, you take care of this. And that's called the map phase. Okay, the map phase is taking that search log and mapping it to various processors in the cloud. When we talked about the cloud computing, remember we said, I could spin up multiple servers on Amazon servers if I'd like and process whatever I want for a fee, right? It's in the cloud. I don't know where these servers are. I don't care. It's fairly cheap. But that's what we do with the map phase. So we take the work and we break it into these processors, and we say, you guys analyze this, 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 maybe count the keywords. The reduce phase, then, is we say we got to bring all that information together. So maybe John's computer over here counted this keyword 18 times, and Nick's computer counted it 36 times. So we need to bring that information together and make sense of it, and that's the reduce phase, right? So map it, it goes across all kind of computers. Reduce kind of brings it together, and it all happens in the cloud. Now this is a technique, but the computer language or the computer software that does this, the most common one is something called Hadoop. Has anyone ever heard of Hadoop? Okay, Hadoop is it's a software developed by Apache that does this. Okay, it takes this free format. I guess an example of this would be, you ever seen a word cloud? You guys know what a word cloud is? No? They even used one on the debate last night. You guys know what a word cloud is? No? Well, I saw it on Monday when we analyzed my Wolfram Alpha, my Facebook. Remember it had a word cloud, like what was the most common words Dr. Nico used in his post? You guys remember that? And the size of you guys remember that? Like congratulations was big, dad was big. You know what I'm saying? You guys ever see that? That's an example of, okay, taking free-form text and trying to analyze and say, what's the most common phrase, right? So taking all, that wasn't an example of big data because it's not that big. But if we took everyone's Facebook posts and did that, that's an example of big data. So I guess a nice example of this, when we talk about search history, that is definitely an example of big data. So Google has a site that is an application of big data. So if you guys, and you guys can do this as well, if you have your laptop out, go to Google Trends. Has anyone ever used Google Trends? No? Good, then you're in for a treat. So if I go to Google Trends and I go up here to Explore Topics and I type in St. Francis University. Okay. Google obviously analyzes all their searches. And they don't just analyze it, they analyze the heck out of it, right? They look at every aspect of it. And this is for the phrase St. Francis University. This is the search interest over time. So unfortunately, it looks like St. Francis University is kind of, and it goes, they capture this monthly, so that's why you see spikes. It's not really smooth. But it looks like we're trending downward, right? But we could also look at not just St. Francis University, but maybe look at, one of our competitors. Whoops. How about, I don't want Juniata. I want Juniata College, okay, which is one of our competitors locally. So we are the blue, and they are the red. So it looks like their search history, more people are searching for Juniata College than St. Francis University. Let's pick one that I know will beat. Let's do Mount Aloysius College. No, they're not going to beat us. Okay, there they are, yellow. They are not good. Okay, now if we add a term like, I don't know, maybe, let's say Harvard. Okay, and this is a logarithmic scale, so, it doesn't really show you how many searches. It just shows you, like, relative to one another. But when I add, like, Harvard University, what do you think is going to happen? They're going to dominate us, right? They're going to dominate everyone. So, boom, there's Harvard. And relative to Harvard's search history, there's ours, okay? So if we X out of this, I don't know if you guys watched the World Series this year or the playoffs, the Major League playoffs, but one of the players that definitely did better in this playoff season than he does typically is the Mets' Daniel Murphy. Okay, he had like a home run in like 8 straight games or something ridiculous. And if we look at him, he kind of peaked, right, in October of this year. Daniel Murphy was not someone that was searched for a great deal until, October of this year. And, man, he really took off because, who the hell is this Daniel Murphy, right? Like, so if people get caught in scandals, crimes, they typically peak, right? If they become
mainstream. I mentioned, how many people watched the Republican debate last night? 0? For real? That's why you guys don't protest. Missouri, they just got the president and the chancellor fired. Did you guys see that? You guys know what I'm talking about? University of Missouri just got the president and chancellor fired.
What?
You guys don't know this? Yeah. Okay. He didn't really make any racial comments, but there's racial tension in Missouri, and he didn't really address it, right? He kind of like blew it off, and then students started protesting, and then finally the football team said, "Hey, we're not playing. We're not." There's 30 of them, I think 30 football players said, "We're not playing until the president resigns." Well, he resigned, and then the chancellor's resigning at the end of the year. So, that's the kind of power that students have. You could get me to resign. If you have a protest, Dr. Miko said something, that would work. Please don't, but you could do that, right? So no one watched the Republican debate last night. Not one of you. Huh?
This is like this morning.
How about, did you see anything from the Republican debate? No highlights. Wow. All right, well. All right. Tell me someone involved in the Republican debate last night. All right, Marco Rubio. Which some people say I look like him. Yeah, all right. Who else? Ben Carson. Who's the big guy? Who gets the most publicity? Donald Trump. Carly Fioroni. I always say her last name wrong, but Carly Fioroni. I like her. Kasich. But if we look, Google. If we look at, they have under Google Trends, Republican debate 2000, the last debate. They have a lot of things here that you can see. So what are the top search issues during the debate? Taxes, right? That's a big Republican initiative. They think taxes are too big, government's too big. They want less taxes, a lot of them. Flat tax, immigration, minimum wage, Obamacare, economy. Here's the top search GOP debaters. But what's kind of cool is they also have, and this is, as the debate was going on, well, here's the one I want to see. As the debate was going on, they, at the time the debate was going on, started at 9 o'clock in Milwaukee, and at 11:24, and they tracked who was getting the most search hits at a given time. So I'll replay that, see if I can replay the race. So at the beginning, okay, Ben Carson. So usually it was people that had camera time, right? Well, so they're saying something, they have a minute or something. So people are like, what the hell? Who is this person? Or what's Ben Carson think about immigration? So Ben Carson had the most searches. Marco Rubio second, Donald Trump third. So this is, think about it, real-time information. And further, if we look at it, I think there's a most searched by state, which is nice, right? You can see who was searched most by state. But they even have it down to county. Okay, so this is all the counties of the United States. So they know that, hey, John Miko was searching for, Marco Rubio and blah, blah, blah in Cambria County. So if we zoom in, okay, let's see if we can find, we're in Cambria County. Where the heck are we? I'm too close, I can't tell where I'm at. Okay, there we are. There's Cambria County, so we click on Cambria County. Donald Trump was the most searched Republican presidential candidate, followed by Marco Rubio. That I do see a lot of Trump for president signs in my neighborhood, which blows my mind, but I do. So Marco Rubio second. What's this county? That's Blair County, so that's Altoona. That's Bedford County. Rick Santorum, what are you kidding me? Where's Center County? I'm not good with geography. This one? That's Center County? So that's State College, so it looks like Donald Trump won there as well. So this is an application, you think about it, this is an application of big data. Think about all the searches that were done across the United States,
And they were able to break all that information down by time, by county, what were the things concerned with, and produce this, right? That is a good example of big data, right? So taking all kinds of information, trying to make sense of it. Other thing, let's see what else we have under Google Trends. These are the top trending searches right now. Veterans Day in school, maybe, do I have school? Texas Veterans Day, so obviously Veterans Day. Yik Yak, University of Missouri, must be related to the scandal there. Veterans Day, New Jersey, cryotherapy, I don't know what that's about. Looks like some of the, so you can kind of see what's going on in life via Google Trends as well. Football season. You also see, for example, some search topics are seasonal. For example, let's do our football team, St. Francis University football. So you would expect, right, there's only interest in St. Francis University, most interest in St. Francis University football during the fall, right? So this is, November 2010, this is fall. So, in the summer, no one really cares. April, no one really cares. May, no one really cares. So you can see, some searches typically are seasonal. If you, trend yourself, let's see, I'll do myself. There are a few other John Mikos in the world. I'm friends with one from Australia. So if we put John Miko, and I'll do it first, my boss, Randy Fry. Okay, looks like I'm dominating Fry, so which is nice. But anyways, pretty cool application of big data, right? Pretty cool application of big data. And everyone, there's something called clickstream data. Clickstream data isn't just what you search for, but what you clicked on, where you clicked on the screen, how many times you clicked, how long you stayed, how long you watch a video. And recently Facebook came out and said how many video hits they get, how many video watches they get. And it's funny because Facebook, I think if you watch a Facebook video for 3 seconds, they count as a watch. YouTube has a higher standard. They say you have to watch it for 30 seconds. So you're not comparing apples and oranges. You're comparing apples and oranges. So a lot of neat stuff there. A lot of neat stuff with data. Okay, so let's go a little bit further. So Google Trends, Hadoop, talked about that. The last concept in this chapter that I want to cover is knowledge management systems. Okay, so when we talked about, remember the first slide we talked about, we said, 4 sources of data. We said the first one is what? Operational data. So it's just data generated from us operating our business. Then we talked about social data, like relationship data. This is your family, this is your friends, this is what things you've liked on social networks. The third thing we talked about is purchase data. So things that we can buy to fill in the blanks. Like we can go out to Axiom and similar data brokers and buy data. And the fourth type of data, which is really, really important, is our employee knowledge, right? Employee knowledge. And knowledge management is the process of trying to capture that knowledge, either employee knowledge or customer knowledge, and sharing. So anyone have an example of this, why this might be important? So let's say you're the, Apple iPhone help desk. Why would knowledge management be important? Say you're in charge of the Apple iPhone help desk. Tom.
You gotta know what you're telling the people that are asking for help.
Okay, so I call you, Tommy, and I say, I have this issue with my iPhone, right? There might be 50 Tommies that work for iPhone help desk, probably more than that, right? Maybe a couple hundred, right? So you don't know what's wrong with my iPhone. You don't know how to fix it. But what's likely? You don't know, but think about it. What's likely?
Somebody else will.
Somebody else probably, they've seen within that whole organization, with all those, hundreds of people working on iPhone help desk, someone has seen this issue before, right? Maybe you haven't, maybe it's new to you, but maybe the guy, cubicle 3 down, had that issue just yesterday and solved it, right?
That's what knowledge management is all about. Knowledge management is trying to share that, because you might not have bumped into them in the break room and said, hey, I had an interesting problem with an iPhone, I think. That probably didn't happen, right? But what could you do? What if the company is doing it right, what can they do?
Transfer you to someone else.
Okay, well, you might not know the guy down the hall had that issue. So you can't say like, talk to me, right? You know. So what would be a way that you could maybe do that, Tom? Well, there's a couple hundred people. You're not gonna be like, hey, who had this issue? Maybe you would. You have a very strong voice, so you might be able to do that. But what more likely would you do? Yes.
Like log the way that you learned how to do it.
Okay. So if we, as we're capturing, as that person 3 cubicles down from you fix that issue, they would log it, right? And that's an example of maybe big data, because it's not going to be, they're not going to write this issue the same way that maybe I would write this issue, right? You would write a paragraph saying, seemed to be that the problem was that when removing the battery, that something to that effect, right? So we would log that free form. That's fine, we have that information logged, but we need it to be recovered at the time where it's useful to us, right? So it's got to be something that's searchable, right? So a lot of times, knowledge management in an organization, has to provide some kind of searchable structure that we can say, there's someone who had a similar issue. And it's not just help desk. Some of you will end up leaving St. Francis and being consultants, right? You will be consultants. You'll be managerial consultants. You'll be pharmaceutical consultants. You'll be higher education consultants. So you'll go into a place like St. Francis, and you'll do an analysis, and you'll say, here are the issues at St. Francis. Students can't get email, right? That's an issue. But maybe you'll say, here are the broader strategic issues. And you're not just going in with your base knowledge, because maybe you work for Accenture or a large company. Accenture has done thousands of consulting engagements, right? By thousands of people. That is the baseline knowledge. So you're going to say, you might start with, you know what? Mary over here did an engagement with Juniata College, and here is the documents she produced and the issues she found. So that's the baseline. That's the baseline. But I didn't do that engagement. I don't even know who the hell Mary is. But I can use the information that Mary created for this aspect of our job. So that's a really important thing in large organizations, especially knowledge organizations. Not just, I want to know what I want, I know what I know, but I know what everyone in the organization knows. So a lot of companies employ something called one of the things that you can do, you mentioned, I would ask, you go down and ask John. That's good, Tommy, because some companies employ what's called a rich directory. Like, if you guys ever go out to myfrancis.com and try to find a phone number, we have a university directory, right? So you go John Miko, and it shows a little picture of me, and it shows my number, my office, all those things, right? A rich directory, some organizations employ that, which it would show, John Miko, it would show all my information, but then it would say, like, he's an expert at this. He has done, if I'm a consultant, he has consulted for universities. He has consulted on assessment issues. He has consulted on big data, whatever it might be. He has filed these reports, right? So now I can search that directory, and I don't only search that directory for people, but I search it for skills. I need someone that speaks Arabic, who is also an expert at big data, right? Do we have that within our organization, within our thousands and thousands of employees, right? Because we don't want that information to be siloed. We want it to be shared. And that's what knowledge is all about, creating value from intellectual capital and sharing that knowledge with those that need that capital. So your knowledge isn't just your knowledge, it's the organization's knowledge, right? It's the organization's knowledge. So preserving organizational memory by capturing and storing lessons learned, best practices of key employees. So that's another benefit of knowledge management. People leave you, right? It doesn't matter how good of an organization you are. People go, they leave you for other opportunities because they wanted to move, because they got more pay, because they were just burned out, because they got sick, whatever it might be. But you want to try to capture their information. So that's what we do with knowledge management. And one type of knowledge management system is something called an expert system. Okay? What an expert system is a series of if-then rules. When we did the module on coding,
guys remember we built a little Excel macro? We coded some if-then rules. Like if this condition happens, then do that. If this condition is true, then do that. Well, an expert system is trying to take something that a human does intuitively because they're knowledgeable and code that as a series of if-then rules. And the example the book uses is, think about a doctor, right? A doctor runs tests, right? They want to see what's wrong with you or how healthy you are. They run the test. You think about those variables are really decision points for the doctor. They say, well, I don't know, your cholesterol is above this number, and also your blood pressure is here, and this is true. So they come out to say, we're going to diagnose this or recommend this treatment. You think about it. That's kind of what a doctor does, right? Now, he or she has years and years of experience, and they've seen these nuances, but what we can do is try to capture that knowledge, right? We can try to capture that knowledge and code it as if-then systems. So if cardiac risk factor is no, if the patient's sex is male, then add 3 to cardiac risk. If patient age greater, then add 2. So we're trying to assess, is this person at risk for a heart attack, right? That's what an expert system does, but it just doesn't do it in the medical world, but maybe it does it for loan decisions, right? We could say, does it have this? So expert systems are trying to capture, codify, if you will, the knowledge of an expert. Why? Because experts are expensive resources, yes? Experts are experts for a reason, and they come at a cost. So expert systems are trying to codify that information. Some have been better than others. There's some difficulty with them. They're difficult and expensive to develop because we have to talk to experts, we have to code it. Difficult to maintain if something changes. It can have unexpected results. And it's really tough, right? Doctors still have that, they can handle nuances better than computers, right? They can still say, well, I can look back at things that maybe we can't capture quantitatively and make decisions on that. All right. I just kind of want to summarize this chapter. Okay. There's some things in there that about the hypersocial organization. We're not going to cover that. But what we're talking about in this chapter is we take all this data, right? All these data that we can find, operational data, purchase data, employee data, social data, and we want to analyze it so that we can be a better, more efficient, more effective organization. We talked about all these types of BI applications, RFM analysis, OLAP, market basket analysis, decision trees, data mining, expert systems. We didn't really talk about RSS feeds. And we have results, and then we want to get that information to people that can use it, our BI user, our business intelligent users. Now, when we get that information out there, there can be push or pull, dynamic reports that they can push, or reports that come out on, or monthly reports that are pushed, or dynamic reports that are pulled. Okay, so that's what we're trying to capture in our organization. Okay. All right. So, any questions on Chapter 9? That kind of covers Chapter 9. Okay. So, what I would like you guys to do, we don't have as much time as I thought. I'm going to pass this up. This chapter has seems like I don't have enough copies. No, I don't have enough copies. I have 22. All right, never mind. Give those back. I'll do this Friday. Okay, so tomorrow, if you want, please join us for the talk from the Pittsburgh Pirates and the data analyst and who use these kind of things. And as I said, if you write a paragraph on a big paper, because I don't want to read a big paper, if you want to write a big paper, I'll give you 2 bonus points. Okay, so 8 o'clock he's in Business 101, 9:30 he's in Paddle 110, 11 o'clock he's in 206, 1:15 he's in Paddle 110. Okay. I will see you guys. Have a great Veterans Day. Find something to protest.